is an innovator and architect from Samsung Research and Development. His interest lies in creating a unique user experience and solving user pain points with technology innovations. He has over 14 years of experience and is working on mobile platforms and on-device AI with a focus on keyboard engines, language, and text intelligence. He has earned a master's degree in data science from Liverpool John Moores University and is pursuing a doctorate in business administration from the Swiss School of Business and Management, Geneva. He has published 6 IEEE papers, holds over 40 patents, and has commercialized various solutions in Samsung smartphones. I would now request Mr. Barath Raj to address the gathering. Over to you, sir.
Thank you. Good morning, all. Great to connect with you all, and honored to be part of this session, especially from Professor KP Rao. Right, so wonderful session, sir. Thank you so much. And thanks Arun and team, and thank you IEEE section Bangalore. So I'll share my screen.
Harshita, can you stop the screen? Yeah.
So I hope you can see the screen in slideshow.
Yes, we can.
Yes, thank you. So So most of the talks that Professor KP Rao has given, right? So I can connect it totally, the evolution of the scripts and languages, right? So I will go a little specific in one area with respect to typing, generally a keyboard, right? And I would be covering what all technologies involved in this digital typing era. Right, so mostly I will cover what kind of layouts. I will just generally introduce keyboard, what kind of technology slowly connected with the Indian languages, how should we tune each of these algorithms or artificial intelligence. So keyboard, right? So this is kind of most touched application. So from Samsung smartphones, right, we can see almost like every day, almost like 60 billion keystrokes happens every day. So keystroke meaning you tap on a particular key, and you see this prediction area, right? Every day there are 2 billion predictions picked, almost like 2 to 2.5 billion. The auto correction happens, right? I'll explain about it. Probably might be a jargon for some of you. I'll explain each of these technologies involved. So this is a kind of on-device AI. For example, so I would say in Samsung this was one of earliest AI technologies. So when we type, how do you recognize each of these characters, or how should it predict what kind of artificial intelligence involved and all that, right? And also the technologies, you can see the technologies, most of it that are involved in the keyboard, you can connect it to this text intelligence or NLP, language processing, because it involves most of the language techniques, right? So this is a kind of a basic for the typographical errors, right? So how do you avoid them? How do you fix them? So how do you overcome such typographical errors? So I would touch briefly on each of these technologies, right? So you can see a QWERTY keyboard here, and the dots you're seeing in different colors, right? Just to differentiate, we have put them in the different colors. So these are the areas that user has typed. So if he types a particular sentence, he might come across the same character A or S multiple times, and these dots are actually meaning that every time user is pressing on that particular key. And what we have observed is every user has a different pattern. So how do you so if you look at, this is a space, right? And each of the keys in the space, user will tap, right? So what kind of spatial model occurs? So we have explored a lot of mathematical functions like Euclidean, Mahalanobis, and we have found that Gaussian performs well. So you have a key, you have a lot of placements on the key, right? And what is a kind of standard deviation with respect to mean of that key? So if mean meaning a particular center of that key, right? Where user has typed, not user is what user is seeing, but where user has typed. There could be a mean and there could be a standard deviation. So this is a technology we kind of involve to avoid, especially with respect to this kind of keyboard layouts in digital world. How do you avoid these neighboring errors? So for example, if you type between A and S, right? So what kind of spatial model you'll encounter to resolve this ambiguities, to resolve these conflicts and predict the right character? And you are seeing this white portion, right? But there are a lot of empty spaces. So internally inside the keyboard, what we have done is, so it will grow gradually. So for example, A, you might type more compared to SQW. So the portion of A should grow gradually, right? So we adopt such, this is a kind of from big data, from observing a lot of users. We kind of preload a model which understands kind of regular user pattern, which is a spatial model. Later, when user starts typing in his own device, right? So each of these areas will grow according to this Gaussian model. So this is a kind of basic touch model when you type. And still we can see that a lot of typographical error happens, right? So we come up with a lot of innovations, a small continuous innovation in each of these areas to avoid this typographical error. So something like, for example, character language model. So so something like for example, it understands the character sequence for each of this language, right? So how can you build this character language model from ngram LMs to RNNs or LSTMs? How can it be a lightweight? So there are constraints, right? If you tap, it has to respond immediately, not more than 30 to 50 millisecond it should take. So what kind of compact LM we should consider, right? And so what type of character LMs we should consider? For example, there can be from the world's data, right? From the corpus, we build this character LM. Then user types. Then we will build a user character LM on device, and there can be a contextual character LM. So that's where LSTM kind of models that can understand the longer sequence and build on device. When user is typing, it understands the context, predicts the keywords, build a contextual character LM on device, and then it will help in predicting the next character. So we interpolate all of this, a touch model, character LM, contextual LM, all of this, and understand how can we avoid neighboring errors. So this is one kind of area where one core technology in keyboard. This is first part. The next one, right, is about is about continuous input. So till now we talked about typing. This is about swiping, right? So user can swipe. So for example, if you want to type testing, user will type like this. I mean, swipe like this. So many of you must be aware of this technology, right? So traditionally, what is involved? So if you swipe like this, if you tap on a particular key, assume this is a space, you will get a XY. Assume you're swiping, you will get a lot of XY positions. So like in a millisecond, you will get 15 to 25 kind of XY positions, keystrokes, right? And when you do this, there'll be hundreds and hundreds of keystrokes will be there. And how do you take all these keystrokes, process it? So for traditionally, a lot of things like with respect to distance of the keys, is there a slope, or what is the distance with respect to mean of each keys? We can filter each of these keys, finally predict. Traditionally, it would be like this. And there are recent advancements with respect to, so what if I build a neural network, right? If it takes each of these keystrokes along with those timestamps, some people will swipe very slow, some people will swipe fast, right? So each of these keystrokes along with this timestamp and distance to each of this. So when you swipe, so you can see that there is a distance with respect to mean of each keys, right? If you can feed all of this to a kind of, assume it as a bidirectional LSTM model. So how do you filter each of these keys? For example, if I'm swiping boy, I might have swiped like this, right? So a lot of keys will be there. How do you filter and predict this? So that is one. So you can compare it with dynamic time warping. It's a technology used in speech models. Right? You will have a lot of intonation and all that, and you might speak fast or you might speak slow. So there is a kind of wave you will form, right? So you can relate it the similar technology here. So you swipe like this. Some people will swipe very fast. Some users will swipe very slow. So how do you kind of map? There will be a kind of ideal ground truth for the swipe, right? It consider it as a waves now. So if you can map it, so whichever is the closest match. So if you can interpolate both of them, this DTW, dynamic time warping, as well as this bidirectional LSTM models, how can we bring out or predict such characters? So these are some of the technologies involved in continuous input swiping, right? So we have seen typing and swiping. And if I come to this Indic layouts, right, like we support 22 official languages, and slowly it is growing. So at present in Samsung keyboard and Samsung smartphones, right, we support around 40 plus Indian languages. So except for few of the languages, most of the languages follow this kind of layout, right? So there is a vowel and there is a consonant like this, and you can use this key to this kind of to enter these kind of diacritics, right? So what if I want to apply this touch model? So you have a lot of keys here. So obviously the neighboring errors will be more, right? So what we have invented here is this bigram position aware touch model. So it's very simple. So for example, you tap on a key, you find a standard deviation, right? So if you, for example, if you type a particular character from bottom and towards ka, if you type, right, it might be at the bottom. So if you the previous character, if you type, for example, da like that, and go back here, the placement of this key will be different. So if you take a bigram touch positions, right, with respect to previous key, for the current key, where am I touching, right? This touch positions can be easily classified, especially with respect to this kind of Indic layouts or Devanagari layouts, right? So we can see that this touch portions are in different positions, and the mean of it or standard deviation of it is very different for each of this key. So we have invented this to classify this touch model further for especially for this Indic layouts. And you have seen a lot of keys, right? What if previous to QWERTY layout, we used to use the small phone with 3x4 keyboard and all that, right? You can see that A, B, C, D, F, all these are combined 3x4 keyboard. So what if we can combine, I mean, each of these characters or each of this row as one particular character, right? So this is a kind of innovation we have been trying. So there can be two ways. One is you can physically see this on the device, or it can be virtual in the backend. All of this can be considered as the same key. And then what if instead of user typing on this, if we give it to the algorithms, right? For example, if this is a keyboard, I want to type Dekna. So I will type just one second stroke here and third stroke here. So instead of particular, typing on that particular, keys, just in the portion of this keys, and then disambiguate it with algorithmic approaches. Like, for example, you have a vector of keys here, vector of second stroke here, vector of keys for the third stroke here. Then you have this vectors. How do you disambiguate and then predict this kind of letters very easily just with the keystrokes? So we in beta we have observed almost like 60+% we can save keystrokes or it can save a lot of neighboring errors. So the similar for continuous input or swiping as well. So you start like this and then end like this. So it understands all these keystrokes which placed on each of these buckets, a bucket of vector of each of these rows, and then predict each of these characters. So these are some kind of innovation happened with respect to Indian layouts, right? Now till now we have been talking about I want to type in regional layout and typing this regional scripts. So what if I want to type in English layout itself? There is a targeted segment of users who want to type in English, and then I want the script should come like transliteration, right? So again, traditionally the technology involved here, we used to map these kind of, so many people will use different spellings, right? For example, some people use HI, some people will use HE, may, for example, MEIN, some people will use MAIN, some people will use, or MEI, some people will use, right? So how do you, formulate such rules or maintain such hash? How do you, for example, how do you actually bring such rules itself? That's a kind of innovative area we need to explore. And using the language models, which is a kind of, assume this is a prediction engine, and using this context and the rules, how do you map and then bring or predict this kind of transliterated words? So this is a traditionally, this kind of technology is involved, and recent advancements for, of course, this is about neural transliteration. So we have this encoder decoder models, right? So for example, you have a particular sentence, you have a transliterated sentence, you feed it to the neural networks for example, bidirectional LSTMs. And of course, the recent advancements with respect to this dot product attention, that is giving better results with respect to transliteration, right? And now I'm typing in English characters and I want Hindi characters to be published. What if I just want to type it in the English character itself? I don't want Hindi characters, but type. So there is a targeted segment of users who prefers typing in English itself and send it in English. So we call it Macaronic LM, right? So these are some technologies that are involved with respect to Macaronic LMs, especially for Indian languages, right? So character CNN. So compared to the English or other Latin scripts, right? Especially with respect to Indian layouts or Devanagari languages or other Indian languages. So for the same word, lot of spelling will get used. So character level models are kind of greatly helpful with respect to Indian languages. For example, if instead of creating a word to vec embedding or other embeddings, right, or one hot encoding and all that, so we have tried this character level embeddings. So for example, you have each of these characters, what kind of, you can set a buffer, what the size of each of this character level embeddings, and compute a weightage of each of this character level buffers. So if we do that, the model performs far better compared to other embeddings. Of course, we have tried through highway. You also pass the word level embeddings as well as the character level embeddings, and then build a LSTM model. So this kind of model gave a better performance with respect to especially Indian languages. So we have also innovated on the pseudomorphisms, right? Especially with respect to Indian languages. So for example, kar raha hai, if you want to type karenge. So kar is a root word, and there can be a lot of combinations, right? So if you can build a hierarchical LSTM or hierarchical RNN model. So for example, there is a char level embedding followed by a subword or a morpheme based embedding. So we call it pseudomorphisms, and then the word level embedding. So if you do build such kind of hierarchical RNNs, right? So for Indian languages, especially, it is performing far better. And there are some innovation related to semiotic LM. So for example, so if you can represent some of a group of words into a particular category, for example, NER, right? So entities, for example, so all the names, all the person, all the people, all the organization, something like that. If you can, in the corpus, if you can remove all these names and give a tag, for example, hashtag name, something like that, right, in the corpus itself. So what happens when you're predicting such sequence, right? It will predict a tag, and we will know when you are inferring it on device, we will know that, okay, when the tag is there, right? What should I do? How should I process? So should I do autocorrection and all? So especially with respect to Indian languages, right? Aggressive autocorrection is a major issue. So because the model doesn't, because there are a lot of spelling, lot of words, the model doesn't understand all the words. Obviously, it fall into this OOV, out of vocabulary category, right? So we can use such techniques, semiotic LM, for example, so that the vocabulary size also will get compressed, and you can build a better model. So these are some kind of advancements which with respect to Macaronic LM. And there is another issue I discussed, right? People will type different spellings. So one kind of tip. We have tried this and it worked better. For example, people will type, sometimes people will type two A's, sometimes people will type single A, right? Kya bhai, something like that. Different spellings will get used. So what we have done is we have built offline statistical model. So we need to form these rules, right? For example, there is a Milne. If I type, I might type Milne, or sometimes people might type Meelne, for example, right? And when you feed language models based on this sequence or sequence probabilities or from the LM scores, right, we can derive using the statistical model such rules. For example, I is mapped to EEE in different context. Likewise, we don't need to manually do or bring all this for bring out these rules. Just give it to the statistical model and identify such rules. And that worked far better with respect to this word variant disambiguation. So this is kind of an innovation we have done. And yeah, so now we are in English layout, and people. So we have built a lot of Macaronic models, and we have solved a lot of problems, right? But some of the users don't even go download that those language packs and all that. So this we recently introduced in some of Indian models like A series and M series models in Samsung. So what we have done is in English layout, user is typing and using a compact language detection technology. So we will understand what language user is typing and give a smart pop-up like this to enable this multilingual texting. So then predictions from both English dictionary as well as, for example, if user is typing in Hindi English, right? So both from English and English dictionaries we will compute and will give them kind of multilingual texting prediction. So some advancements with respect to language detection, right? So two things. One is we have a lot of languages. So when user is typing in English layout, we need to understand which is it Hindi, is it Marathi, is it Punjabi. We need to understand that. And second one is we need to do it on device. So for example, I am typing a particular word. It will not take more than less than 200 milliseconds for a word, for example, for each character taking some 30 to 50 milliseconds, right? So we need to do it on device. We need to understand the language, do a lot of processing on the device. So what kind of innovation we have done here? So one big data analysis we have done, right? So we have just computed character language models, character n-grams, for example. We just kind of a matrix, right? Each of these languages and the character LM probability. So if I give a particular character combinations, for example, ABC, in which language is it used more? If I understand this char LM probability for each of this language, we can clearly see from the big data that the character language model can easily solve language detection. Now, what is the second step? We use different vocabulary size or different corpus for different languages and build these character models. And it's not straight away comparable. So what we have done is a simple, logistic regression models. So it's a kind of stochastic process, right? So for example, there is a character probability and there is a kind of weight and bias for each of these languages, meaning each language is different, each corpora we use for languages are different. So that's why there should be a weight for each of this language based on various parameters, and there should be a bias, right? So, and if you it's a kind of stochastic process. So for example, you assign weight from 0 to 1 for weight and 0 to 1 for bias, and run for each of these 0 to 1 combinations offline, and then you can compute for each of these languages what are the weights and bias for each of the languages. So when you get a log probability like this for a character model, we need to multiply this with the respect to languages weight and bias. So this is just a initial value log 0.5, for example. Sometimes it can be 0.8 or something like that, right? So if it crosses a particular threshold of probability, then we will predict that this is this particular language. But we have to do it on device, no? So we have done this kind of parameter optimization. So all of this weight and bias, if I can compute, I can compute like this. I mean, you can derive it this way. So log p minus this particular t value is greater than or equal to a particular threshold. So this t, right? So we will compute it offline instead of doing all this computation on device, if you can build such t value offline, then you get a log probability for each of these languages. Just subtract it with this parameter t, then you will get the actual probability, meaning the probabilities are normalized. So these are some of the techniques, or to bring it on device. We have done some inventions here. So till now we have been talking about regional layouts, typing in regional script itself, or typing in English script of the regional languages, right? But the English itself, the English layout, the QWERTY keyboard itself, how it should be different with respect to Indian scenario. So there are various different language models, right? EN US for US layout, UK for UK layout. Traditionally, we have been using UK layouts. We just compared how is Indian users using these kind of different vocabulary. So mostly we can see that it's a kind of small set of beta users. We have seen that English US words are mostly used compared to English UK, even though most of the times we preload with English UK words. And so this is a kind of small comparison. So for these kind of 146 plus 56 words, 80 to 100% of times US word or US spelling is preferred. So for example, there are two things. One is, for example, socialize, right? SEZE we will use, different spelling we will use. Or color, LOU or LOR. We use different spelling. What kind of spellings we use? So we usually prefer US spelling. This is one kind of insight. Another one is the word itself. For example, movie and cinema, right? Like with a lot of examples. So 55% of users prefer using US language. So having said that, of course, EN US layout works well for Indian scenario. So having said that, there is a need for this Indian layout also, which we have been working. So meaning, so what happens generally if you collect the corpora with respect to Indian scenario, right? So a lot of regional words will come into picture in the English corpus itself, or a lot of names with respect to India and all that. So EN IN obviously is recommended. So this kind of, only with respect to English layout, what kind of these are some of the insights we should consider. These are some insights, and this is the last slide. So we have seen for each of these applications with respect to input, what kind of technologies involved, right? And these are kind of some of algorithmic optimizations, right? Specifically with respect to Indian languages. Of course, so for example, so how can you optimize the vocab storage itself? Right. For example, I'll give an example with English, so that you can easily relate it to the Indian vocab scenario. For example, there is a word accordingly. So you can split it into. If you look at the vocab, there might be three kind of words present, right? Accord, according, accordingly. So what if only the word accord is placed in the vocabulary, and for according you will point to the same index, only ing I will add, and accordingly I will point it to the previous index, only ly I will add. So you can easily relate it to morphemes, right? The root word and the combined affixes, for example, right? So if we can store especially with respect to Indian vocab, for each of these languages, it can save a lot of vocab. It can compress this dB size a lot. This is one kind of optimization. Second one is related to embeddings. We have seen Karen and char level embeddings, or morpheme related embeddings and all that. So what if we use a TF IDF vectors? For example, you have a word, you split it into a root word and affix word, right? And treat it as a different word, and assume you make a TF IDF vector, right? So you can see that this particular root word and this particular affix word combination will be higher only in this kind of vocab. So this will also save a lot of space and learns these vectors better with respect to the language models. And these are some tricks. For example, so we need to every language will have 100k, 200k, 300k vocab or of different sizes, right? I'm talking about on-device models, and we need to fetch this vocab. So particularly with respect to what kind of data structure that you use is very important. So there are some open source, so you can look at them. For example, Marisa is one open source, or Cedar kind of tries are available. You can get inspirations from such tries. So for example, what is the right data structure we should pick to store it in the vocabulary, or what is the right data structure that we should use to retrieve it? Each of this milliseconds, 10 milliseconds or 20 milliseconds that you use to store, retrieve and all that, right? It plays a major role with respect to this fast typing scenario. So and last one is of course with respect to caching, right? So you might use Keras, TensorFlow kind of frameworks for building these language models and all that, especially with respect to this when you're building this on-device model, when you inferring it on device, caching helps a lot. So for example, it saves almost for example, initially the inference time, if it takes around 300 milliseconds, 400 milliseconds, with caching you can bring it down to 30 milliseconds to 50 milliseconds easily. So meaning you need to consider caching the weights, caching different LM scores of the model. So how do you store what kind of information about the networks or the activations, right? So what kind of information you will store or cache, that is important. You need to explore, you can explore in this area. So that's all from me. So hope the session is useful. So you can ping me here from baratraj.kr@samsung.com if you have any queries. We can discuss or we can collaborate offline and be a part of this evolution. That's all from me. Thank you. Hope I was not fast.
That was excellent. Thank you, Barath. It was really interesting. To understand what happens when you have data at the scale that you have, that would be really fascinating. Thank you.
Thank you.
A few questions. Sarna, will you take them up?
Yes, sir. So there's a question which says, millennials use emojis to more to express. Is Samsung working on emoji predictions for Indian languages?
That's correct. So so till now I've been, so the focus is on the languages and all that, right? So this is about sentiment analysis or emotion understanding. So there are a lot of, so of course, yes, the answer is yes. We have already commercialized or innovated in this domain with respect to emoji search, emoji predictions, or recently we have also introduced real-time sticker suggestions and all that. So again, so if we have built a kind of hybrid model, right? So for it can be as simple as you have a word, you have an emoji, you just map it and bring it. Or what if I want to understand the sentence, understand the emotion, or build a DNN model, for example, what kind of BiLSTMs you want to build, and predict the emotions and predict the emojis, respective emojis. So there were few insights. So for example, right, around, we have around 1,800 emojis, right, in emoji, or maybe more, with respect to this Unicode chart, right? And we have observed that from big data, it's a kind of beta users. Only with 100 emojis, we can cover 90% of the users. So we should tune more for those 100 emojis rather than focusing on a lot of emojis and all that. There is also another insight with respect to emoji combos that we have recently patented as well. So a combination of emojis. So people will use not just one emoji, right? People will use multiple emojis. So how do you use this combo, and what percent of people, this combo of emojis are used? All these are very interesting insights from big data. Yes, of course, the answer is yes. We are working on such technologies as well. So, for this session, we didn't include such topics here today. Yeah, I hope that answered the question.
Yes, sir. Thank you. For any further questions, Mr. Barath has shared his email ID and he can be contacted directly.
Yes, sir. Thank you. Thank you for the opportunity too.
Thanks.